Hi, welcome to today's lesson. Today I'm going to look at what completing the square means with relation to the actual graph of the parabola. Okay, so using completing the square, okay, to graph. Okay. Now, the reason why I'm doing this is because when they actually ask you to sketch a parabola, you're going to have to look at 5 things. You're going to have to look at the two intercepts of the x-intercepts, the y-intercept, the turning point, and then the axis of symmetry. Always those 5 things whenever you sketch a parabola. So, I'm breaking this down into a couple of steps. Now I'm just going to be looking at what the turning point is with relation to completing the square. Okay, so here's what they give us. They give us e.g., okay, y equals x squared plus 4x minus 3. Okay, and in addition to that, they give us this pretty picture. And the pretty picture does this. And that's my turning point. Okay. And they say, work out what the turning point is. Okay, not a problem. I know from my theory that the turning point is when I get it into completing the square form. So let's do that. Alright, so I'm going to move this guy and I'm going to get him into completing the square form. Like I said before, I'm just going to worry about that for now. So I'm just looking at the x squared plus 4x part. Alright? So, what is this? This is x, same sign, plus half of that, 2 squared. Fix the 2 squared that's going to pop out of there, minus 2 squared is 4. Right? So that's that. Now I'm going to put it back into there and take that minus 3. So I've got x plus 2 squared minus 4. And I'm going to put the minus 3 also in there, minus 3. And we just tidy it up. And our part's the complete of the square version. X plus 2 squared minus 7. Okay, fantastic. Very, very straightforward. Now, here's where the theory comes in. A lot of people just learn off by heart that that turning point is the opposite sign of that and the same sign of that. But it's good to understand why it's the opposite sign of that. Okay. Here's the theory. I spoke about this a little bit in the last video. The minimum value of this thing, let me just do this. The minimum value of this thing, the least that this could possibly be, alright, is when this is 0. Why? Because as soon as this is anything else other than 0, let's say that x plus 2, let's say that equals 1, alright? X is negative 1. 1 squared is 1, right? That's going to be negative 6. Not the lowest it can possibly be. Let's say at negative 10. I think, no, if I push x low enough, it's going to be down there. Negative 10. Negative 10 plus 2 is negative 8. Still quite low. Squared is positive 64. Bear with me. So then this is going to be way high. Positive 64 minus 7 is what? Positive 37. 57. Sorry, 57. Okay. So that's going to have such a huge influence. Okay. This only influence, the least that influence this can have is when this whole thing equals 0. So the least influence the bracket can have is when the bracket equals 0. So when x plus 2 equals 0. That'll be the smallest influence it'll give. It'll be no influence. It'll be 0. So then what does that mean? X has got to be negative 2 if I solve that. Okay. So when x is negative 2, the bracket is nothing, which means that there's no influence on the smallest number, which means the smallest number is negative 7. You're with me with that? So this turning point now, this lowest point here is negative 2, negative 7. Because when x is negative 2, that's as low as the parabola can get. If the parabola is upside down, then it's as high as the parabola can get. Okay, so that's a maximum instead of a minimum. But positive a's usually result in positive in minimums. Always result in minimums, not usually. Okay, this leads us on to the theory. And this is the theory that people learn off by heart, but I hope that this explanation has helped you understand why it's like this. If I've got the form y equals x plus p squared plus q. Plus p minus p, it doesn't really matter if you know the idea behind it. Okay? Then my turning point is at the coordinate opposite sign minus p, same sign q. Okay? So my turning point is the opposite sign of that for my x coordinate, same sign as that for the y coordinate. The reason why it's opposite sign of that is because of this thing. I make that equal to 0 and I solve it. Are you with me? Okay, it's because that is what makes the bracket 0. That's why it's opposite sign. Are you with me? Okay, now this is very important because when you know the turning point Okay, you know things like your axis of symmetry. Okay, and if you look at the other blog input that I've got about using completing the square to derive the quadratic formula, I also talk about what it means where it's left and right, okay, of the axis of symmetry, and a shortcut for working out the turning point from this form as opposed to going through the whole completing the square jazz. Alrighty, okay. Well, that was a short one. Hope you enjoyed it. Remember, there's more on the blog, more on the channel. Yay, you know, remember I'm here for you.